SpaceX has been in the news a lot for the past few months. Back in May 2021, SpaceX successfully performed a high-altitude flight test of the Starship rocket. Now, SpaceX is getting ready to perform a flight test of the whole Starship system with the Super Heavy booster stage powering it. For those of you who are not aware of the Starship project, it is an orbital rocket being developed by SpaceX that Elon Musk plans to use as a transport rocket in his goal to colonize Mars. But what makes the Starship such a unique rocket? According to many industry experts, that would be SpaceX proprietary rocket technology that is being developed specifically for the Starship. That is the Raptor rocket engines. Let us take a look at how the Raptor rockets work and why they are the best rocket engines ever made. A brief look at the Raptor program. Elon Musk started the Starship program because he wants to help humanity become a multi-planetary species. Elon Musk envisions that humankind has reached the technological level to finally start thinking about colonizing other planets so that we may grow as a species. But becoming a multi-planetary species is easier said than done. With the Starship program, Elon Musk is tackling the first major problem of colonizing other planets. That is, how do we get people and stuff to another planet? Starship is SpaceX's and Elon Musk's answer to that. A spacecraft designed to carry crew and passengers on a long-distance journey to not just Mars, but other planets in the future. But to successfully achieve that, Elon Musk had to not only rethink rockets, but also rocket engines. And since Elon Musk is a big fan of vertical integration, the Raptor engine program was started. SpaceX would design and manufacture their own engines for their interplanetary transit vehicle. For Elon Musk, three things were important in making their rocket engine. First, the rocket engine should be completely reusable with minimal servicing. The second, it should be cheap to manufacture. And the last thing was that the technology would be made as simply as possible, so it was easier to scale. These were the goals set for the Raptor engine program as it evolved throughout the years. How the Raptor engine works. The Raptor engine works on a thermodynamic cycle called the full flow staged combustion cycle. Without making this a lecture on university-level thermodynamics and literal rocket science, let us take a very brief overview of how the Raptor engine works. The full-flow staged combustion cycle works with two separate turbines. One is oxygen-rich and the other is fuel-rich. These two turbines drive the fuel and oxidizer turbopumps. The oxidizer turbine is driven by high-pressure gas generated by combusting nearly 100% of the oxidizer flow with a fraction of the fuel flow in an oxidizer-rich pre-burner. The fuel side uses the full fuel flow with a small fraction of oxidizer to generate the pre-burner gas that drives the fuel turbine. The Raptor uses separate turbines and pumps on the fuel and oxidizer. The boost pumps deliver the necessary inlet pressure for the operation of the main turbopumps to create a combustion chamber pressure of 270 bar. This is the highest achieved by an operational liquid-fueled rocket engine. The reason SpaceX went with a closed-cycle engine is that it makes the engine more suitable for reusability. Other benefits of using this cycle are that it allows the turbines to run cooler. This is due to increased mass flow. This ultimately leads to longer engine life and higher reliability. An engine with longer life and high reliability means it can be safely reused multiple times without servicing. This will significantly cut down costs and downtime between launches. According to SpaceX, the Raptor engine is currently rated for 50 flights. Making fuel for Raptor on Mars. SpaceX made a very interesting design choice with the Raptor engine. See, most rocket engines use RP-1 or rocket propellant as their fuel. RP-1 is basically a more refined version of jet fuel. In fact, previous engines made by SpaceX, like the Merlin engine that powers the Falcon 9, also use RP-1. But for the Raptor engine, SpaceX decided to use cryogenic liquid methane as fuel. This was a little confusing at first, but SpaceX later explained the reason for going for an engine that runs on methane is that if we look at the geological landscape and atmosphere of Mars, we can see the abundance of CO2 and frozen water on Mars. SpaceX plans to make its own methane on Mars by using a process called the Sabatier process. The Sabatier process uses carbon dioxide and water to make methane. Oxygen comes out as a byproduct. If SpaceX can make their own fuel on Mars, there will be no need to carry extra fuel for the return journey to Mars, as there will be local fuel available to refill the Starship. It is a very well thought out plan. This whole process comes under the philosophy of in situ resource utilization, or ISRU, which is a concept about ways you can use local resources to your advantage. And the Raptor engine was made with ISRU in mind for Mars. Performance of the Raptor engine. It's not enough that the Raptor engine is using an unconventional thermal cycle. What everyone cares about is how it performs during operation. One of the most important things that scientists look for in a rocket engine is its weight-to-thrust ratio. The weight-to-thrust ratio of a rocket engine is calculated by dividing the amount of thrust the engine produces by the weight of the engine itself. The higher an engine's weight-to-thrust ratio, the faster it will accelerate. The Sea-level Raptor engines have a weight-to-thrust ratio of about 107, and SpaceX is aiming for a final weight-to-thrust ratio of 200. This is really impressive if we compare it to other rockets. For comparison, Rocketdyne RS-25 has a weight-to-thrust ratio of 73. RS-25 powered both NASA's Space Shuttle and their Space Launch System. Or if we take Energomash RD-180 that was used for the Atlas III and Atlas V rockets, it has a weight-to-thrust ratio of 78. Even Blue Origin's BE-4 engine sits at a weight-to-thrust ratio of 80. How does the Raptor engine compare to other rockets? So how does the Raptor engine fare against other rocket engines? It is important to note that different rocket engines are made with different uses in mind. So we will be comparing the rockets in terms of cost and performance. Cost. According to SpaceX, each Raptor engine will cost them $2 million to manufacture. This is insanely cheap when compared to the Rocketdyne RS-25 and the Rocketdyne F1 engine used by NASA that each cost $50 million and $30 million respectively to manufacture. Now, if we look at it from a cost per thrust perspective, we will see that the Raptor engine wins again. The Starship's Raptor engine costs $1,000 per 1 kilonewton of thrust. In comparison, the RS-25 costs $26,881 per 1 kilonewton of thrust produced, while the F1 costs $4,431 per 1 kilonewton of thrust produced. And since a single Raptor engine is rated for 50 flights of reusability, we can bring that cost down to just $20 per 1 kilonewton of thrust produced, which is absolutely insane. No other rocket engine comes close in terms of value. In terms of reusability, we will see that most engines weren't designed with reusability in mind. Usually, rocket engines were made to be good for one flight, but we see that the Raptor engine can do up to 50 flights. In comparison, the BE-4 engine by Blue Origin can only do 20. SpaceX wants its rockets to be reusable and be ready for consecutive flights with minimal servicing. The Raptor engine might not have been the very best at everything, but the reason the Raptor wins in the end is because it does everything really well. It is cheap to make, has a good thrust-to-weight ratio, and is cheap to operate, making space exploration more accessible. The Raptor engine truly is a feat of modern engineering.